Hey everyone, this is Ben with Biamp. Today we're diving in to soft codec mute sync with the EX-UBT. Tesira is certified for mute sync with Microsoft Teams Rooms, Google Hangouts Meet, and Zoom Rooms. We'll talk about what mute sync is and how to set it up in the software. Let's get started. Mute sync is the synchronization of the mute status between a soft codec and an AV system. Without mute sync, the soft codec can mute and unmute without any communication to the AV system. Some soft codecs can send mute and volume information over the USB connection to the AV system using HID or Human Interface Device data. A Tesira system using an EX-UBT can interpret this HID information to establish mute sync and act on the mute state of the soft codec. We want mute sync in a conference room so that when a user mutes the conference call on the controller, the AV system can react to mute the microphones and give visual feedback by changing color on the microphone's LED ring. Here's a configuration for a conference room with two Parlay ceiling microphones, a PoE Plus amplifier, and an EX-UBT. To set up mute sync, you need to build some logic connections between four blocks: the Parlay microphone block, the Parlay processing block, and the USB transmit and receive blocks. Starting with the Parlay microphone, double-check we have logic inputs control LEDs selected in the block parameters so we have the right logic inputs on top. The LED 1 and 2 logic inputs will turn each mic's LED ring on when high and off when low. The RG1 and 2 logic inputs control the LED ring's color. A low signal will turn the LEDs red, and a high signal will turn them green. Next, on the Parlay processing block, this mute logic input will mute the microphone's post-AEC processing, which is where we want to mute to maintain convergence. The EX-UBT USB transmit and receive blocks each have logic outputs for USB connected and streaming states. Most importantly, the mute state of the USB transmit block is where the HID mute sync information from the soft codec is reflected in the software. We will use this node to drive the LED color change and processing block mute. Here's what it looks like with all the logic connected. First, I have the connected and streaming states of both USB blocks going through an AND gate and then into the LED 1 and 2 inputs on the Parlay microphone. That means the signal will only go high when both the transmit and receive USB blocks are connected and audio is passing. I also have the mute state of the USB transmit block connected to the mute input on the processing block. This ensures that anytime the soft codec is muted, the microphones will be muted as well. Finally, for the LED color logic, it is important to remember that on the Parlay mics, the LEDs turn red when the RG input is low. That means we need to put a NOT gate in between the mute state and the RG inputs, so when the USB transmit block is muted and has a high output, the NOT gate will flip that to low and make the LEDs turn red. Let's take a look at this configuration in action. I've connected the EX-UBT to a Zoom Room system and pushed the configuration. As you can see, as soon as the room starts or joins a call, the USB audio starts passing and the Parlay LED rings illuminate since both connected and streaming go high. When the call is muted from the touch panel, the Zoom Room sends the HID signal through the EX-UBT and the USB transmit block mutes in the configuration. From there, the logic we set up turns the LEDs red and mutes the mics in the processing block. The HID signal for unmute is also sent to the USB transmit block and acted upon in the configuration. That's it for this time. I'll put some links in the description below for some related Cornerstone articles. If you have any questions or want to see a video on a different Biamp topic, let me know in the comments. I'm Ben with Biamp. Thanks for watching, and I'll see you next time.